So in this question, we have energy. We have a graph, so let's do our analysis of the graph, Oe Zerga. The origin is here. Well, we're not really sure what the origin is. We don't know what H, I, J, K, L, and M are, but at least the zero value in the Y is there. The Y-axis is energy, measured in joules. The X-axis is distance, measured in X. So any question about energy or distance would be read off the graph. Now the slope would be energy over distance. Energy over distance. Well, we know work is force times distance. We might rearrange like this and get work divided by distance. And work divided by distance then would be the force. Aha, so the slope is the force. And the area is work times distance, which is not a quantity that has any value to us. All right, so potential energy of a system as one object moves along an x-axis and the rest of the system does not move. Evenly spaced points are labeled. At H, the object is moving in the positive direction. All right, so at H, it's moving in the positive direction. And so what we see at point H, from H to I, is that the potential energy stays the same. So what we're seeing then is that the height must be the same. Oh, and we were told that initially with 5 joules. Well, so that means there's originally 5 joules here like this. So if this is the potential energy, then this must be the kinetic energy. So the kinetic energy would be 1 in this case. So if the total energy is 5 and the energy is conserved, which we would expect in a system, we'd have a total energy of 5. So what we see then is the kinetic energy is increasing, then remains the same, and then it decreases to 0. So the thing stops at M. All right, so we see this thing is speeding up, velocity increases, and then velocity remains the same, and then velocity decreases. What we see in this phase is the height decreases, height remains the same, and then the height increases again. That's how we should interpret that. All right, so which segment does the net force exerted on the object have the greatest magnitude? The net force, well, the force we said is the slope. So they're asking when is the slope the steepest, and that is LM. And if we look at HI, during HI, there's no change in energy. IJ, there is change, but it changes 2 units over one distance. And here we have it changing 3 units, so it's greater L to M. JL remains constant, so those two are out, constant, and IJ is less than LM.